Here's example 14 of solving trig equations. So here we have sine squared of x minus cosine squared of x equals negative cosine of x. And we're solving this in the interval 0 to 2 pi. So again, what that just means is 0 is less than or equal to x, which is strictly less than 2 pi. Okay. So this one's a little more complicated than the previous example because now we have sine squared and a cosine squared, and we also just have a cosine of x floating around over here. So actually what we're going to want to do first in this one is use a trig identity to get rid of the sine and just have everything in terms of cosines and cosine squared. So what is there an identity that we can think of that relates sine squareds and cosine squareds, or maybe sines and cosines somehow? So yeah, there is that really, really important identity, sine squared of x plus cosine squared of x equals 1. Okay, so what we can do is subtract cosine squared of x from both sides, so then sine squared of x equals 1 minus the cosine squared of x. Okay, so sine squared of x is 1 minus the cosine squared of x, so then we can take this sine squared of x, and this exactly equals 1 minus cosine squared of x. Okay, that is that, so then the equation then becomes 1 minus cosine squared of x. Okay, this is our old sine of the squared of x. And then we still have minus cosine squared of x, and then still equals negative cosine of x. Okay, now we have like terms that we can combine. So 1 minus cosine squared of x minus another cosine squared of x equals negative cosine of x. So this is 1 minus 2 cosine squared of x equals negative cosine of x. Okay. Now, what sort of thing does this kind of look like? This equation, what does it kind of look like? So just like in example 13, well, what do we have here? We have cosine of x, and then cosine of x, and then the whole thing is being squared. So in example 13, we had a sine of x, but the point is the same in that we have something, okay, here's a thing, and then here's that thing being squared. Okay, here's a negative cosine of x, or the negative doesn't really matter yet, but here's a cosine of x, and then here's that cosine being squared. So a thing and then a thing squared. What type of equation is that? Well, it's a quadratic equation, right? It's a type of quadratic equation anyway. So what we're going to do now is make a substitution. Just like we explained in example 13, the substitution just takes this equation and turns it into something simpler that's easier to work with, and something that's more familiar to us, so that it'll be easier to work with and we know better what to do with it. So let's say let a equal cosine of x. Okay. Then a squared equals cosine of x, that whole thing squared. But remember, the shorthand way of saying that is cosine squared of x. Okay, so then this right here, here's a, okay, cosine of x, that's a, and then cosine squared of x, this right here is a squared. Okay, so then what the equation becomes is 1 minus 2a squared equals negative a. Okay. And how do we solve something like that? Well, this is now just a plain old regular quadratic equation with a as the variable. So now what we do is we get everything on one side so that 0 is on the other side. So let's go ahead and we don't really want a negative sign in front of the squared term. So there's a couple different ways to handle that, but let's just do this. Let's add 2a squared to both sides. And then we'll also subtract 1 from both sides. Okay. So then what happens on the left is we just get 0, and then on the right we get a 2a squared minus a, and then minus 1. Okay. So now this is the equation we want to solve. So let's come up here. So let's just swap the sides around for no real reason. 2a squared minus a minus 1 equals 0. Okay. Now we can factor this, so let's go ahead and factor that. And how are we going to factor that? That's going to be 2a plus 1 times a minus 1 equals 0. Okay. So now 2a plus 1 equals 0, or a minus 1 equals 0. Well, here, if we subtract 1 and then divide everything by 2, we're going to get a equals negative 1/2. And then over here, just add 1 to both sides, and we're going to get a equals 1. Okay. But again, we're not done yet. Okay, we're not solving for a, we're solving for x, right? Solve this equation, we're solving it for x. So now we have to back substitute, we have to undo this substitution. So now that we know that a is negative 1/2 and a is 1, now we can use the fact from earlier that a equals the cosine of x. Okay? So if a is negative 1/2 and a is the cosine of x, then what we have here is cosine of x equals negative 1/2. Okay? And then from here, so this really is, we're taking this whole thing now, moving it up here. So if a equals negative 1/2 and a is also the cosine of x, then cosine of x equals negative 1/2. Similarly, if a equals 1 and a is also the cosine of x, then cosine of x equals 1. Okay. And negative 1/2 and 1, those are special numbers associated with the unit circle, so that's great. So that means from here on out, it's just a matter of knowing the unit circle. Okay. So if cosine of x equals negative 1/2, what are the values of x in this interval from 0 to 2 pi? Which values of x have cosine of x equal to negative 1/2? Well, those values of x are x equals 2 pi over 3 and 4 pi over 3. Okay. And if cosine of x equals 1, if we think about the unit circle, which values of x in this interval from 0 to 2 pi, which values of x have cosine of x equal to 1? And the only one, there's only one of them, the only one is x equals 0. Okay. So cosine of 0 is 1, and that's the only value of x in this interval here that has cosine of 1. Similarly, cosine of 2 pi over 3 is negative 1/2, cosine of 4 pi over 3 is negative 1/2, and these are the only two values of x with cosine of negative 1/2 inside of this interval. Okay, so that's the final answer then for example 14 of solving trig equations. 2 pi over 3, 4 pi over 3, and 0.